Okay, I just put something together, kind of talk a little bit about the history of things and how it progressed, and then kind of where we are now. So um, I'm going to kind of go through this kind of quick because it's just probably all somewhat familiar. But okay, yeah, NetCDF came out of a number of things. CDF was a NASA project. There was a lot of discussions about, how to do this in a machine independent way, portable, shareable, self-describing. That was anyway. That all kind of was happening. NetCDF came out. HDF has been around since then. I think HDF4 and so NetCDF late 80s. CF started. Well, the precursors to it, chords and other things, started in the 90s, and then CF itself 1.0 came out in 2003. So that does the descriptions of the geophysical meanings of the data, and geolocation of it, and all that. So units and whatnot. And I'm just gonna jump forward. Oh, right. And so the big focus in CF and with NetCDF really was n-dimensional gridded data. So that was a fairly straightforward thing in there, and describing it was important and figuring that out. But there was always, even in the first version of CF, there was some observational stuff, trajectories or aircraft track kind of things, and soundings and station time series. So there were some descriptions about those, and that was expanded and clarified in 2011. So that's kind of a side note because a lot of this focuses on gridded data, but I think the observational stuff is really important too, and figuring out how that moves forward is, and it's actually fairly widely used. Some of that in NOAA, and some of the observing, ocean observing, I know uses a lot, and others. So, okay. And then along with all of this was developing this ecosystem of tools and visualization analysis. Models were being, IO for models was being added. Parallel NetCDF came along. Lots of things going on. So that ecosystem is kind of an important aspect of this NetCDF CF environment, and it's the similar things with HDF and others, and there's a lot of crossover because things like the CDM, which I'll get to in a second, and NetCDF Java, which was kind of the implementation of the CDM, just went across all these and tried to pull all of that into this data model that NetCDF CF had put together. Data collection. So lots of data was out there as well. Okay, and then along came OpenDAP, and thanks, James, in the late 90s or so. And I guess the important point here is it brought NetCDF and HDF together in all these analysis tools. So, and not only seeing the ways that they didn't match up in terms of types, data types, and interesting things, but also how they handled strings and how they handled other various details was really important, and as well as bringing together things like CF and HDF EOS and how those all map together. So, and again, the NetCDF Java library kind of did a lot of that on top of it. Well, we'll get to that in a second. So, but anyway, we saw a lot of these ways that things don't quite fit together, even if they seem like they're so close, and OpenDAP intentionally made it so that you saw them in the same way, but there were differences that we had to deal with. And that's kind of when realizing that there's all these different kind of extensions, or that NetCDF 3 was very simple, HDF 4 had more complexity, OpenDAP had things that neither of them had. So bringing together this data model into the common data model was driven by this aspect, and it merged CDM. Okay, so CDM NetCDF 4 was kind of the result, at least but it merged together the different data models of these three things: NetCDF, HDF, and OpenDAP. and kind of tried to combine them. And again, there were always corner cases that we'd run into in later times and have to figure out the special mappings between different things, how to handle that. The common data model as a data model is this abstract thing that doesn't cover all the corner cases often. Usually data models are abstract and have a little detail left out. So sort of. So you need to figure out that. And that's, I think, an important aspect of this whole process. Right. Okay. So that was kind of the history that I'm like just leading up to now. And okay, so current status, we have the common data model. As a data model for just the arrays, the structure of the arrays and metadata. So there's that aspect, and there's mappings you have to have that are specific, between things there. And then it also covers some of the metadata, the CF type metadata, and how to map those coordinate systems and whatnot. Anyway, so there's a few different layers, and you have to be dealing with both using it to think in a broad way of how to map all these things together, but then also recognizing that there will be situations where you need to have special information to deal with it. Okay, NetCDF is, I guess, so I'm jumping to the ZAR aspect of things, and NetCDF had created a while back the NetCDF C library and Java library support for ZAR, and it was called NC-ZAR, and it had some of these mappings between data types and other things that didn't fit into ZAR. So just extra metadata, extra information to help it map. And that is currently at ZAR version 2. So this kind of brings us up to now we have, anyway, ZAR is at version 3. This mapping doesn't support that. GeoZAR is bringing together GeoTIFF and CF-NetCDF kind of in two worlds, and the two worlds coming together. And that's an interesting not collision, but it's an interesting merging of concepts and recognizing the differences between there. So I think this is kind of the direction we're headed. And I just wanted to mention the OGC and CF and NetCDF are mapped into some of the OGC abstract models and fit in there. So they're officially part of OGC, or not part of, but accepted by OGC. But the interesting thing in that whole experience was bringing together these different communities. The GIS is very 2D focused with some, I say 2D plus. They deal with it in other various ways. I think the Earth observing and satellite imagery has a lot of 2D imagery, and then it's kind of a plus above what I think the GIS world thinks of data as. Some data. And then, now I use this other term for what Dave called in the title, cell-based spatiotemporal. Somebody else at some point had said time-varying continuous spatial fields. Anyway, there are different ways of thinking about things and different concepts. And so bringing these groups together is an interesting process that needs to be thought about as we're trying to develop common language and whatnot. So it just makes language is hard. Communication is hard. So a few challenges that I thought I'd just point out. I think making sure that we're bringing kind of the ecosystem of tools and data along with us. And I think we're doing that. There's a lot of activity around that, building the bridges. So GeoZAR is bringing different kind of aspects together. The virtual stores are helping with that as well, with the making existing data, enabling that for current and newer things. And then NC-ZAR and the like are trying to do that for the tools. So the NetCDF ecosystem of tools, bringing ZAR into that world will give a lot of momentum with people currently using those types of tools that aren't ready or willing or interested in moving to different tools. So making sure we spin people up along with us, I guess. And then, That was really short. Okay.
That's perfect.
Thanks. Yeah. So I think now, Dave's going to be up. Is there any questions? That was just kind of history overview. We probably all have it. Anything, comments?
Not the question, comment. That's great history overview. Can you put back to the slides before just the last slide, that one. Thank you.
Just a quick, there's been a lot of talk about ice chunk in this meeting. Can you talk about how ice chunk fits into this list on top of czar?
Well, I think the virtual stores is kind of where ice chunk and yeah.
Yeah. Can I add something here, Ethan?
Of course. Yes, please.
Yeah. IceChunk is built on top of Czar in a domain agnostic way. So it has its own specification, which is kind of relevant here, that they do have a spec for how you use IceChunk on top of Czar. And then it would, for geospatial data, either stored as native Czar, which is like the bytes of data themselves are Czar, or virtual stores, which means like the raw data is stored in netcdf or geotiff. IceChunk would use GeoZar conventions to understand the geospatial meaning. And the people who built IceChunk at Earthmover have started doing this in some of their APIs and services, like the Flux service, which uses the GeoZar multiscales that I'll talk a little more. So just like very brief recap, IceChunk itself is domain agnostic, but it can use some of these standards that we need to build bridges between.
Right. And I think on the netcdf side, I think figuring out extension for the NCZAR, which Dave has proposed some ways of doing that, and I think we're going to talk about that some more, and probably Dave will talk about that, and that's kind of a lot of the questions. Yeah. One more question in the room.
This is the world's toughest question. But it gives me pause to note that HDF netcdf is a 1990s technology. Is there any pathway to Czar that doesn't go through netcdf? Is that the world's dumbest question? Maybe I just don't understand. But
well, yes. I mean, you can write Czar.
As I've gathered from IceChunk is that it's hard to parse the netcdf, and that's a lot of work, especially with like level 2 data. And so I'm just curious, is there some
I don't think
about moving away from netcdf ever?
There's a lot of data written in netcdf. It's probably not going to get rewritten. So that's one aspect of it. I think the level 2 issue is not a netcdf versus R issue. It is a level 2 is hard to deal with the coordinate systems, and that it's just not as clear or not as nicely gridded, or various things. So I think that's kind of a separate issue, but it definitely needs addressing.
Let me chime in there too, Ethan. Like, there's some definitional issues there that we need to be careful about, because the network common data format isn't it's not typically decomposed using the same breakdown as other data sets. And so if you look at netcdf CF, like, they've had kind of a culture of complete specification and not a lot of modularity. And as a result, what is netcdf is pretty monolithic. But in fact, there's netcdf constructs that are kind of the metadata that sits on top of a binary encoding, and netcdf3 is its own binary encoding. netcdf4 is some of the netcdf constructs layered on top of hdf5, kind of. And there's just a lot of like granularity of components of the standard stack issues in that question, even, right? And I think it's there in terms of moving to the latest technology. Going through netcdf could just mean relying on the convention that variables have shared dimensions. Like that's a NetCDF construct in my worldview. And it's all, there's basics like that are always there and aren't necessarily problematic. So
Yeah.
Max?
I think this is a great question, and I think a lot of people probably have it. And I'm wondering, in my mind, we could build a flowchart for deciding what data format and constructs you use and why, whether that's directly to ZAR or to NetCDF, then to virtual ZAR, or just to NetCDF. I think that's a tenable goal to have and something like an ESIP cluster could put together. It doesn't exist now, which is part of the reason why I think it's very confusing for people who aren't like thinking about these formats and standards every day for so many hours a day to keep track of, and it changes over time. So it's a super valid question.
Yeah, I like that idea. We got a question in the room.
Yeah, I'll just respond. Anthony Alstenkamp, Limnotech, recovering academic. So I've been kind of on the fringes of climate forecasting. I'm trained as an oceanographer, but mostly doing watershed work in these kinds of, and soil data and groundwater modeling and kind of fringe cases in which the data sets are not natively produced as NetCDFs, right? And we just started writing data, like just taking data that either comes out of a model as like CSVs and just writing them straight to Xarray and then saving them to ZAR. So like you do not have to go through NetCDF to get there. One example is pFlowTran, which is DOE's groundwater reactor transport modeling. It's a 3-dimensional thing. It writes HDF5, and my colleagues working at DOE on this project, like just could like they were really stuck with like visualizing and understanding the data. And so if you just understand this shared dimension concept, right, that and basically I was able to create a little script that parsed that HDF5 in this kind of wonky format into Xarray. And then save it to Xarray, and then I have access to all these tools. And so there are lots and lots of paths for it to make this work. And I think that the CF conventions and the common data model are great, and we don't have to go through NetCDF to get to them.
All right, let's keep moving.
We have one more question from Tom.
Sorry, one more. Tom from Earthmover. So the question is not stupid. It's the same question that everyone else is asking, right? It's like we have shitloads of data in formats that were not designed.
I didn't know I work for NASA, so probably not going to be doing CSV files, but yeah.
Sure. But the point is there's enormous amounts of data that, for various reasons, are unlikely to be duplicated, or people can't afford to duplicate it or whatever. But they are fundamentally unsuitable for the cloud in their current format. And NetCDF is one example of this, but not the only example. I think the HDF5 on disk is one example of this. And so the question, there's basically two questions. Is like, how do you give users a better way to access the archives? And that's what the virtual ZAR thing is for. And that's what we had the whole session on Tuesday about. And then there's this separate question of like, should we be making different recommendations for data generation going forwards, right? Which is what he was getting at.
NASA's not going to redo all their old archives. For sure.
Right. So there's like a compatibility problem, and then there's a forward choice problem. And with the forward choice, some groups are starting to like write directly to ZAR. That's still like relatively unusual. Some very, very enterprising people might be writing IceChunk. In the private sector, they're quite happy to like switch and write to like IceChunk, right? They have like less inertia going on in some cases. But the reason that we keep getting all these like HDF files and grid files and stuff is because like the supercomputer simulations like produce these types of files, and that's what they write to disk. And then and they're like a good technology for that. But then when they get, schlepped up to the cloud, they're not suitable anymore. So there's this like other problem of like, okay, what should we do about that? Like, should the models write to ZAR? should the models write to ice chunk? Should the models write to netcdf? But then we like sort of require something that makes it easy to do the virtual czar trick later. I don't actually know the answer to that question, but like that's the question that we'd be asking in terms of the format.
The new modeling framework that I'm helping develop for Army Corps, we're writing directly to czar.
Yeah.
Yeah.
Okay.
Yeah, and we're doing it in a chunked way, lazy writing by time step, and so to just completely bypass netcdf.
Yeah, I mean, should we be thinking about tools? Like, should we be building tools for doing that rather than requiring everybody to submit data as nets? Yeah, that's kind of my question. Thank you.
Yeah, I think let's move on from there. I think that's a kind of a different question, but very related. So
Yeah, let's
All right.
let's keep moving. I'll tie that topic off by just saying a good portion of my career at the survey has been
just expand this window or something.
pulling right optimized data that modelers are sharing with an infrastructure that we need to build out in service of data delivery and data availability. And so a lot of my career was converting GRIB and various, somebody shipped me multi-terabyte drives of ASCII grids that formed a time series that I had to convert into an aggregated netcdf collection that we were going to host via threads, right? And so like that right optimized model output that then gets converted into something that's useful in a read context, that challenge is like that's ultimately what we're doing here to some degree. And if we can drive that, just write something out that's reasonably optimized for read-based use cases, we'll win. But that's like not always been easy. So the other thing I'll say is one of the first things I did at the USGS was with a colleague of mine named Tom Konicki. We contributed a GeoTIFF input-output service provider to the netcdf Java Common Data Model. And like the idea of GeoTIFF working in the netcdf ecosystem was half novel. And the idea of like the well-known text projection strings working with CF projection parameters was kind of novel. And we wrote a crosswalk for those for a project called the Geodata Portal. People had done it before, but not in an automated way. And it turns out a lot of that stuff is automatable. It's a little complicated, but we can bridge these worlds. And that's a lot of what's gone on in these communities with the maturity now of Xarray and other tools that help with these kinds of translations. And so first thing I want to do is present this NZ, which I was looking at why the communities had so much difficulty with GeoZar to some degree, and also what is assumed in Xarray with regard to netcdf when it goes from netcdf to ZAR. And basically I said, well, can we write that down so that other people see it and understand that like there's this interoperability that's been implied with how this kind of ubiquitous tooling around Xarray really set the rules for interoperability between these two formats. And so NZ, and what I realized was, there's the netcdf users guide that's referred to in the netcdf CF conventions, the NUG. And it's one of the normative dependencies within CF. There are very few normative dependencies in CF, but it's one of the ones where they just say, according to the NUG, it's this way, so we're going to assume that's the way the world works. And that's good. Like we need normative dependencies in our specifications, and they need to exist at some level. And I was like, okay, well, we don't have the netcdf users guide for ZAR. We don't have that layer of the stack in ZAR to say this is how we things like this is how we relate dimensions to arrays, and those base assumptions, how we handle typing, how fill values and missing data are handled. And when I started looking at that stuff and comparing that to the issue list in say X-ray, a lot of the problems that kept cropping up for the X-ray community were because there were assumptions that were unstated related to these things, and fill value is a big example. The difference between the default value and the null value, and there was all this weird complexity around what should be just kind of written down. This is the way we do it, and so using this was actually early in my experimentation phase with Claude, and it was a really good opportunity for me to exercise agentic AI and kind of learn my way through all this stuff. I decomposed all that, thought it through with my background knowledge of how this stuff all kind of fits together, and I put together NZ 1.0, iterated on it with a few people on GitHub, some really productive discussion, and it's there now in the Czar specifications as a proposal. I implemented it in a couple of R package examples that I work on. It works. It's really just copying what X-ray has. My next step on this is to kind of start poking at the X-ray community implementers specifically about, hey, can we move forward in this? And then also, working with Ethan and the NetCDF team, I think declaring this NZ convention that sits underneath NetCDF CF as a convention is kind of next steps on this NZ thing. And it seems unremarkable, it seems unnecessary to some degree, but it really is this kind of underlying set of basic assumptions that really make all this stuff function. Okay, so the next observation I want to make, and this is, I think, many people in the room are going to be like, yeah, duh. But I think it's worth calling this out. And it's that there's kind of two ways that we look at these data sets. And there's different people who think one is right, or different people whose kind of agenda it revolves around one of these ways of looking at this data. And so we have all these all these interfaces and ways of working with data that revolve around world coordinates. The web coverage service, environmental data retrieval, has NetCDF subset in threads, which I got a ton of mileage out of over the years, allows you to request the data you want according to world coordinates, or the coordinates that you want to operate in. And it's on the server, it's on the host to figure out what those coordinates mean in the context of the data that it's hosting. And then there's these access mechanisms like OpenDAP, the NetCDF API, X-ray directly, where the client application has to have all the logic to understand how to map their world coordinates onto the data coordinates. And one of these use cases requires the client, or requires a really deep knowledge of the data for every user. The other use case basically requires every server that has aggregated a whole bunch of data to have a very specific metadata description of the data they're holding so they can accurately do these coordinate transformations. And neither one is perfect, neither one's right, neither one's wrong. These are just two ways of looking at the data. And I think it's really important to see it through both lenses and understand the problem space, both through the needs of a data archive that has a bunch of environmental data retrieval OGC API services and has to figure out how to wire up the API so that latitude, longitude, time requests make sense against some random data set they happen to have in their archive, as well as like everybody running X-ray against a Czar store that they found in some stat catalog has a clear way to understand the data that they need to work with in terms of its coordinates so that they can wire it up to their workflow, right? And we're working in this space all the time, and I think it's just really important to use these use cases as thought experiments and kind of riff on these two perspectives. Okay, and then, so this is the last thing I'll kind of call out and pass it along, or we can have a little bit of discussion. So historically, threads catalogs were like the thing, right? Catalog.xml, list of data sets, Some people had a data set that was like a big long list of netcdf files that happened to form a collection. Other people would go to the ends of the earth to figure out how to hack NCML to create these elegant aggregations so that a given client could iterate over these big collections as single sets of spatiotemporal arrays. In both cases, the threads catalog was a way to describe the collection of data. And that ability to, and it wasn't just threads, the implementation that Unity had. The threads catalog then got implemented in multiple server implementations. And to my eyes, Stack is kind of being seen as a replacement in that space. It's here's how we create catalogs that contain collections, data sets. And I guess where I've landed on this, we did some work to try to port our threads catalog into Stack. And we realized, well, when you have a fully aggregated ZAR collection, it doesn't make sense to have Stack assets anymore, because the fully aggregated ZAR is a collection that could also be broken out into a bunch of assets in some other set of formats. And maybe it is. Maybe you have a collection of netcdf files that are assets that also can be aggregated into a single ZAR, and that's at the collection level. And so what I guess where I'm at with my thinking about this right now is whether you're doing world coordinate requests or data coordinate requests, there's this idea of a collection. And it aligns with OGC API, which now part 2 of OGC API has this idea of collections. It aligns with those ISO 19115 series. It aligns with DCAT data series, so Dublin Core, ISO dataset provenance, and OGC API, which kind of relates to the ISO, but is really a kind of an independent way of thinking about what the definition of a data set. These things all kind of fit as a Stack collection. And so increasingly, I think I'm seeing us evolve toward this ability to say, well, I have a spatiotemporal array using the Stack kind of data cube extension that has this given structure. It's a long list of variables, a set of dimensions, a set of world coordinates that it exists across. And here's where you can access it via services, either world coordinate services like EDR, or data coordinate request services like ZAR via S3. And then there might be a collection of assets associated with that collection that allows it to be kind of an exploded list that is how it exists in the wild, right? I think this is this is my best current kind of bridge between these various worlds. And it leverages the Stack collection paradigm. I think it works. Like, we vetted it pretty hard, and so far so good. And the reason I present this and why I think it's important is like everybody's working on different things. Everybody's in their different space. Everybody's got different use cases, but identifying the commonality and where we meet in the middle and where these things do actually interoperate, despite no real need for them to interoperate always, is really important. Like, finding these touch points is really important across these different communities. So those are the slides I had. So I'll stop there.
Hey again. That was an incredible talk. I really liked all 3 of your slides.
Thank you.
Would you mind just going back to them? I have a couple of comments that
Sure.
might be helpful on each one. So yeah, so you're completely right that there are these like slightly undocumented or underdocumented assumptions within Xarray that have become de facto standards. And they matter. And a good example that's easy to understand is the shared dimensions one, where basically every netcdf file, netcdf files by definition, like if there's 2 dimensions called time, they are like the same dimension. Like, they refer to the same thing, but and you have to write in the name of the dimension. But in ZAR in general, because it was developed completely independently of this entire field of science, it was made by a malaria genetics guy, does not make that assumption. And all the ZAR stores that anyone uses in geoscience follow that assumption. But the ones they use in microscopy for like high resolution images of like fly brains and stuff, they often don't follow that assumption. So it is very worthwhile to have an explicit convention to encode, like, for example, that assumption. And this is part of the reason why, like, the creation of the Czar, finally getting like a system for having Czar conventions at the summit in Rome that I'm wearing the t-shirt for, is a big deal, because it gives us a formal mechanism for writing down exactly this kind. And I know you've already submitted this convention. I'm just giving everyone else like context.
Yeah, it's good.
That's just a comment on the first. And then on the second slide, sorry, I think you've hit something really important here. But there are important implications of this, right? Because the left-hand column and the right-hand column have extremely different implications for like how your architecture. It's like the right-hand column you can do with just S3, like just Czar in S3. It's a serverless, in the vague sense of the word, architecture, where the only thing that has to scale up is S3. And that's why we like S3, because it does scale up. Whereas the architecture on the left, there's an actually like running server that someone has to like turn on or off that is above S3. And that is very hard to manage. That is the thing that fails with like threads and stuff. And the whole point of S3 is that it's very scalable, and making something that's equally scalable on top of it is very challenging. And so the entire point of like Czar in the cloud is to avoid having to run that server on top wherever possible, which is why the architecture we have at Earthmover makes an explicit boundary between the left-hand column and the right-hand column. Like Ice Chunk is purely in the right-hand column, and that's the primary way that people interact with the data. And then for certain types of world coordinate services, for example, EDR, we have to run a server, but we like charge you to use the server because it costs us money every time you send like a request. And then we call that service like Flux. And it's like open core with XPublish and stuff. But like our platform makes this same distinction that you have made in these two columns. And it makes them for like important architectural reasons. So I think this is like really helpful.
Yeah, and there was a huge misunderstanding over the years of the web coverage service standard that caused just no end to problems in this. And that was that it was actually remarkably hard to request the raw data via WCS. You had to know very precisely what the server had on the back end, and very like down to double float blah blah precision, request the cell edge domain that you wanted to get precisely the grid from the server back. That was the GeoTIFF on the back end. And it was just ultimately different from OpenDAP. And people were like expecting WCS and OpenDAP to kind of exist in the same use case space. And it's like, no, these are very different things.
Yeah.
And we kind of bridged that with EDR, because EDR is more respectful of the data itself and gives you back a subset of the data in the data's coordinates typically. But anyways, that's just more complexity under the cover of this, where this distinction is more important than people necessarily see.
Yeah, thank you. And then I have one comment on the last slide. Sorry, this is the longest comment instead of a question ever. So my hot take about this just stack in general is that, like, if we follow the logic from that we just talked about, like, ideally we want stack to be like an index in S3, like part of the Czar store, and stack becomes a convention that is used in the definition of that like index. Like, it's not structurally that different from like a latitude coordinate in like X-ray or something like that. And having an entire separate like software stack just to serve stack catalogs is forcing you into this more like serverful realm, or forcing you to explode your index in like GeoParquet and your original data in like cogs, which is also undesirable. And we should be trying to like fuse the two things together into one. Which, yeah, I'm just curious what you I guess that's a question. I'm curious what you think of that.
So I've heard proposals to use stack to map Czar chunks essentially So you'd almost duplicate the czar JSON content into Stack. At which point I was just like, all right, we've lost. But yeah, I mean, it's there. I think it's I don't know. I think there's a real performance optimization in one view where you're really using a domain agnostic thing for what it's good for in czar, and then there's this kind of spatiotemporal asset domain optimization that's focused at discovery and indexing, and separating the use cases from a performance and a kind of use case alignment point of view is worth doing. And that's what I mean by kind of we've lost. Like we should be a little more pragmatic than that. But it's a feature that they align so well for sure. So I don't know if that fully answers your or responds to your question, but that's yeah.
Oh, that's interesting. Thank you. I'll pass it on now.
Rich Signal, ex USGS.
Always USGS.
Always USGS. Nice. So this is just maybe tangential topic, but you did mention it, Dave. Like everyone seems to represent model like data sets as stack collections, and I'm wondering why not stack items? Because like the use case I have is like we have all these models, running, and they're all pretty similar, and I want to like search over the model data sets. Like want to find all the model data sets that are the item search allows, but collection search doesn't. And so why not stack collect? I mean, this is probably, again, this is a little bit off topic, I suppose, but like why model data sets as collections instead of items? Maybe it's a question for Max or Tom or anybody else in the room.
I want to phone a friend because Amelia Snyder just wrote up a really nice piece about why we made this decision, and I'm not remembering the specific logic for it. But yeah, there are some very good reasons to keep a coherent data set kind of reserved at the collection level, but the fact that everything is a GeoJSON item and that's what we search for represents a discontinuity to that, and it'd be nice to kind of have both worlds. And this is the perennial issue, because a feature collection is a feature, but it's not an item. And you have this disconnect between GeoJSON as a content model and the OGC API or the Stack API focus on items at this entity level. And it's something we definitely need to figure out. And I think having a collection search is eventually where we land, because OGC API a collection is a data set, and I think that's right. A data set's a collection. And you can represent the collection as an item for search if you really wanted to, but I think that's a bit of a hack, to be honest.
And I think that speaks to kind of why people use Stack in some ways, right? Like it's very simple, it's very hackable. The fact that we recommend collection-based approaches for like czar stores for most use cases doesn't mean that you're wrong for your use case for wanting to use items. I think that option to go outside the broken path is like pretty is a feature of that type of ecosystem like Stack. So I think that we like our role in understanding these standards and how they fit together well is more offering guidance, not necessarily requirements. Like you always have to use collections for this type of data set.
That's well put. I think that's totally true. Should we turn to your part, Max?
Sure.
Dave, hold on. Sorry, we lost you for like 30 seconds.
Oh no. Max had a really
in the middle of what you were talking about. What's that?
Max had a really eloquent response to Rich. It was like awesome.
Oh, perfect. Did you record it?
It's maybe recorded. I'll send it to Rich after this. What is the less eloquent way is don't yuck someone else's yum. Like, I'm not going to yell at you, Rich, for putting czar stores in items if that's what you really want. But I still might recommend collections for a lot of other people.
You invoked the well-worn path metaphor, which I really appreciate. So like, I think, and I would completely agree that, like, if there's a use case that necessitates using stack items in a way that the item is actually a data set, fine. But I think we've generally fallen on the well-worn path. The natural fit is that a nice czar collection that's been fully aggregated is a collection in stack. So
I'm just gonna. This is all reminding me when Threads was developed, we had this whole discussion about this as well, because in their data sets could be nested, and we ended up allowing anybody to do whatever they wanted and treat it as as an item or a collection, and then people did, and it just made it very interesting to try to navigate things. So. But I think you're being much more precise in this, and Threads was just a very early attempt.
There's a whole literature on this idea, and I did a bit of a deep dive on this recently for other reasons, but there's a whole literature in platform engineering around the idea of a well-worn path, or the golden road, I guess they call it in some circles. Anyways, if you wanna go deep on, like, social engineering ideas, it's a good one. So.
All right. Well, we'll have one more question in the room, and then we'll move on to Max's talk.
Dave, I can paste Amelia's response in that document into the notes here, and that way Rich can read it.
Perfect.
The decision to go with collections instead of items for stack, aggregated stack. Sorry, czar collections.
We had an answer to that question scattered around, like, GitLab issues and GitHub discussions and all these crazy places, and very recently asked Amelia to scrape all that together into a blog post. So I just didn't have it at my fingertips. But yeah, right. Let's turn to Max. Go ahead.
Yep.
All right. Can you all see my slides and hear me okay?
I can.
Yes.
Okay, great. So this is going to be like a little bit less of a thought-provoking talk and more just a status update, and for the community to be aware of what's going on with GeoZar. This is a very short talk, so it assumes some familiarity with what GeoZar is. As a very brief recap for those who are not familiar, GeoZar serves to standardize the way in which we encode geospatial metadata in ZAR. So if you have a ZAR store, it tells you how the numbers in that ZAR store relate to, say, coordinates on Earth's surface. GeoZar was originally created by Christoph Knoll for ESA as part of his work at Spacebell back in 2022, and it recently had a revision following the ZAR Summit from a monolithic spec to a profile over composable ZAR conventions. And I'm presenting this because I took over as a OGC GeoZar SWIG at the end of Christoph's term in February. I also organized the ZAR Summit, so I was deeply involved in the development of the ZAR Conventions framework. So this strategic reset from last December establishes ZAR as a profile across these composable conventions, where a convention is a mechanism for registering arbitrary, mostly domain or application-specific metadata in your ZAR model in a way that's findable and discoverable by other users and applications. And the why for this is that GeoZar was really struggling to come to a consensus from when it started in 2022 through the ZAR Summit in 2025. And that was largely because agreeing on an entire unified abstract data model and how it relates to ZAR in one fell swoop was too complex, I think, for the community to adopt. And also there were a lot of concerns about maintainability moving forward. Whereas we very quickly demonstrated in GeoZar in a couple months, really, that small self-contained conventions are how the community reaches consensus, and importantly, are much more tenable for implementers to adopt, which is why I think the community concretely reached consensus, is because they saw the success of it in practice very quickly. So right at this current moment, we're in the process of documenting this reset. So we have a pull request open, which a QR code here links to for a revised OGC standards working group charter. As another brief side tangent into history, GeoZar will be built on top of these ZAR conventions, which are community built and maintained. And then for why I believe we need an OGC standards working group on top of this is that OGC provides essentially the authority that allows large institutions and agencies and the businesses around ZAR to understand where these conventions are coming from, whether they're like licensed in a way that will be compatible with the services they're building, and then lastly, provides findability. Like a lot of businesses won't know to look on GitHub or maybe even know how to navigate GitHub, but they will know to look at OGC's standards. So that's why I think there is a value there of OGC on top of a pure community-based approach like ZAR conventions. In this revised charter, I have proposed to scope the recharter around capabilities. And I think this is where one particular point I would love feedback from the people who have experience building either standards themselves or on top of standards, and how much detail keeps a working group on standards like this focused. So I would really appreciate any comments people have on this PR number 145. At the same time, or actually like more like in the meantime between voting and agreeing on this re-envision GeoZar and writing it down in the charter, we have moved forward. So we have 3 conventions, spatial, proj, and multiscale, that have been proven to work quite well for essentially geotiff-like data. So data that are described by a functional or affine coordinate system and have a coordinate reference system, and then optionally have multiscales on top of this. These 3 conventions are already implemented by GDAL, Rio X-Array, and on the geozar.org website, there's a list of the full implementation. So I would say this has been quite a success. Right now, they're at the version 0.1. They may have breaking changes up to version 1, and we really want people to try to adopt this and give feedback in between that time while we have this flexibility. Where the struggle remains is in explicit coordinates. So this is kind of the framework that Dave was talking about, where you have a lot of ZAR data that has already been produced this way in de facto standards. And how I perceive the challenges here are when they are de facto standards that X-Array just has magically work. No one is like really aware of them. And then when you try to write them down, people hate them. And they're like, wait, why are we doing what X-Ray did? X-Ray doesn't own us. I only work in R. And that has been the challenge of GeoZar even like through today. And this is the slide that really matters for ESIP, because I think we can really benefit from the input of CF, Stack, and the OGC API communities and others for navigating the multiple proposals that exist for explicit coordinates in GeoZar. So I think there's many places where we need each other. For example, the relationships I talked about with explicit coordinates, which are historically driven from NUG and X-Ray, establishing how we want to relate between, like Tom's question with ZAR conventions and Stack metadata. I think that prototyping GeoZar and EDR in a very open way would help the community. And then I'd love to have more conversation about process. So particular ask is to comment on the charter. We have a meeting next week on explicit coordinate handlings. This QR code is to subscribe and add the GeoZar calendar to your calendar if you want to join. And then one thing I've kind of joked about, but I actually think would be really helpful, is like standards leader support group. So there's every time I hear like a lesson about what's gone wrong in the past when like Threads was created, but sadly, I was like in middle school. I'm like, this is so helpful. So I wish we could like continue these conversations and learn from each other, because it's a challenge not only to get the technical details right, but it's a real Honestly, draining experience sometimes to try to steer a community like this. And I think there's a lot that can be learned from the people who are going through this today and who have gone through this in the past. So geozar.org is where you can find out more information. And I'm sorry for aging myself in that last slide, but thanks for listening.
I love the.
All right, thanks, Jim. Next.
Everybody loves that X-ray works, but as soon as you tell them how it works, they're like, "What?"
All right, I guess this is a discussion time, right? Any questions for Max before we launch into open discussion? No specific questions. Okay, we have a question. A little peer pressure does a lot.
Yeah, I'm glad. I was gonna feel like, oh no, we had such great discussions earlier, and then I totally ruined it.
Well, I don't have any really brilliant question. This is Danny Kaufman from NASA ASDC.
Hey, Danny.
I mean, I'm not tracking GeoZar in any way. That haven't been aware of the developments. Just kind of like aware generally that it's happening. And so that's kind of like where my question is sort of like what are some of the things that could be like kept in mind for like the work that's being done to develop virtual ZAR stores for NASA data, that like where GeoZar might intersect with those efforts to create virtual stores, and is that something that there's anything that can be done now to kind of prepare for if GeoZar would intersect with that, or is this sort of a parallel thing that's happening that if we put a lot of Earth science data into virtual stores now with the current ZAR v3, that we'll be totally ready for any changes that come about with ZAR? I don't know if I asked that in a clear way, but yeah.
If I can, if your question is how does GeoZar relate to virtualization, and what recommendations do I have for NASA engineers who are pursuing virtualization of data projects? Is that an accurate rephrasing?
Yeah, pretty much.
Okay. My involvement in GeoZar is mostly driven from the interest of virtualization. So in virtualizing data projects, you're mapping the original data to ZAR, and that includes the metadata. So having a standardized way to do that is like the main driver for what got me involved. So it's highly relevant for where things stand right now. If you're virtualizing GeoTIFFs, I recommend using the geospatial proj and multi-scales conventions to do that. And that will give you support in libraries like DecGeoRaster and GDAL already. If you are virtualizing like NetCDF, multi-dimensional coordinate style data, just do what Xarray does for now, but in the future, there will hopefully be an actual standardized way, not a de facto standard, to do that. And it should only require updating the metadata, not any restructuring of the data. That's a specific, I think, essential design goal. So you might have to do a metadata operation. And I think the community should provide utilities to do that very easily at scale. So that's something to be aware of in the horizon. And then I think I'd just like to hear from you about like what level of information you want over time, and how we can keep you engaged like at the right level of detail so that there's no surprises moving forward. Because not everyone should have to follow the GitHub repository. That'd be pretty boring.
Hey, Max, I've got the mic again.
Hey, Tom.
I agree with everything you just said. I just wanted to add like two things. One is that like the fact that it is even possible to update the metadata in a virtual ZAR store was one of my slides on Tuesday. Like that is a feature of this whole like virtual trick, is that even though you're not rewriting the underlying chunks, you are able to make arbitrary changes to the metadata. And it's very useful because you can choose to homogenize or correct things. For example, make something standards compliant, like GeoZar compliant. The other thing I want to say is in our Array Lake platform, we take this a step further. And when you import your Ice Chunk store, your virtual store, it detects whether or not your data is already standards compliant. And if it is almost but not quite standards compliant, it triggers an LLM to rewrite. It basically suggests changes. And if you say like, yes, I accept these changes, then it automatically like makes a new commit to your Ice Chunk store on your behalf that just updates the metadata, which in my opinion is already like a very nice piece of tooling for solving this problem. Just FYI.
Yeah, that's awesome, Tom. I think DKRZ, if I'm remembering the right acronym, is the climate agency in Germany, has like with is it Browser? Or no, it's not Browser. Anyways, they have a similar utility for CF conventions too. That's I think been adopted by many of the climate providers there. That's pretty cool. The other I think PSA that I shared at Amy's session on Tuesday that I want to reiterate is that if you're virtualizing data that uses components of CF or other standards that changes how data is decoded, you should move those into a different part of the metadata, specifically codecs or data types, not attributes, in order for it to fit nicely in the ZAR model. And I think that's another space where it would be great to have input about how opinionated you want virtualize R or other libraries to do that for you versus just like warn you when it thinks that there's something that's going to go awry.
I want to talk a little bit about the gateway drug here to getting HPC on disk applications to write out read capable or otherwise nice data. And I think I'll maybe seed the discussion and ask Ethan to comment. One of the big areas of opportunity is the NetCDF-C library, because so many existing pieces of software already basically compile around NetCDF-C. And if a new version of NetCDF-C were to support a few key conventions and allow software libraries that use it to migrate forward into a world where they were writing, ZAR to disk that just worked for on disk, but was also portable to other infrastructures. I think we'd be able to make a pretty big step. And I think my question is, are there other opportunities like that? I think the NetCDF-C is the clear one. And looking around the community, I mean, the Unidata community is pretty major academic HPC oriented weather group that does a lot of that kind of work. And I guess especially Ethan, I'm curious if you answer that question and if other people have perspectives. I'm curious.
Yeah, I think there's definitely an opportunity there for having models write without having to do a lot of work if we can get things set up so they can write, so that the NetCDF-C library can write ZAR in a compliant way with all of this. That would be really, really valuable, because that is a big use of NetCDF-C. And I think it'll take, it takes a while for at least the operational models to switch anything. So maintaining or adding that capability would really be a really big advantage, I think, to moving in the direction of ZAR and ability to create it there.
Yeah, oh, sorry. Was Rich going to say something?
Yeah, there's one comment, and we're moving the mic over to Rich. What?
That would allow parallel writes as well, right? Like that's a huge
parallel writes. Yeah.
Yeah. I mean, that's a huge deal for these models, right? Yeah.
Yeah.
I agree there. I think there's also parallel writes are one. And I think there is a lot of accessibility carrots that can be offered, particularly around like browser-based visualization is the one that comes to mind. And I think how we're trying to incentivize a lot of change in the community. So like, I'm curious to hear how many people who are current like Panoply users would be interested in that like layer of the ecosystem where they could, if they use these new features and like update to the next library of netcdfc that can write in this way, that they could have a static website that renders their data really quickly, that they don't have to maintain anything for, et cetera.
Yeah, I think and Panoply uses the NetCDF Java library, so there is the issue of making sure this is done in both of those. The Java is used in a lot of visualization things. So I think, that's a challenge, but not too big of a challenge if we figure out how to move forward with that. I mean, that's part of why I really want the NZ to move forward to be fairly official, and for the netcdfc and Java libraries to use that, implement that to support things. So.
Do you? I'm genuinely curious. Do you think that updating features in Panoply is the only way forward for many users at HPC centers? Like, and the alternative, right, is like use a library that already supports this functionality that's written in TypeScript or something like that. And I want to understand the factors that go into that decision of where to implement these features and what to recommend for users.
I think, that's definitely an avenue to take advantage of, is getting users to switch or to start using early in their careers these tools. But I think we've seen over the years it's really hard, and maybe things are a little different software wise these days. It's a little easier to do things, but it's hard to get communities of people to change the tools they use or the workflows they go through. So, I guess there's always the portions of the community that will switch, but then there's large portions that just don't have the time. They're busy doing research and whatever. And so having that bridge is a really, I think, important thing for bringing the entire community forward.
Other than the kind of Unidata community software stack, are there other libraries that, like, say we did get Xarray to encode NZ court conventions in the ZAR that it writes out that follows those conventions, and we wanted to approach other software libraries other than CFC to do the same? What other libraries would that be that are already in the wild?
What other libraries are using the Java or the netcdf libraries?
No, not necessarily. What other libraries follow those conventions that people are using that happen to work and could write ZAR according to those conventions, but are currently either not writing ZAR or are writing ZAR in a way that's subtly different?
Yeah, I'm going to share my screen. This might be too small for you to see, but this is the list of implementations that are supporting the spatial, proj, and multi-skills conventions, which is essentially like GeoTIFFs and ZAR. And, GDAL is the elephant in the room. Like, It is the way that the entry point for so many other libraries. Other ones that have been quite impactful are open layers for like browser-based visualization. It's very widely used. And then there's some like newer libraries like DeckGL Raster, which we have, which Kyle Barron has built at Development Seed, that does like a faster way of rendering directly on the GPU. So I think this would be the target. And I think that there needs to be a big driving project, in my opinion, and that's been part of the challenge with the explicit coordinates approach in GeoZAR. All of this work was really made efficient by the EOPF project, which is ESA's reprocessing of Sentinel-2 in ZAR. And so they needed this, and it made it work. They paid for it to be implemented in these libraries. And without that, I think it's a little bit, or like more like, to make it more positive, like if NASA were to fund a project that does this for virtual czars, then it would happen, right? And without that, then we're kind of relying on the goodwill of people who are in, like, have other priorities going on to think it's important enough to do it.
This is always the conundrum with OGC activities too, because you'll have a coalition of the willing who can do small things, but only the people who have a major initiative that needs it are the one are able to commit the real cycles. And it's a strength of the model because it actually requires a real need for things to happen, but it also requires a lot of energy from people to make things happen at some level. So
yeah, and OGC has the test beds, which like could help here. I think it's their mechanism for solving this need for real implementations, but it's similar to an old academic challenge where like I have to invest so much time to find the funders to be able to do the work. And if I had the work, if I had the time, I would just do the work. That was a pessimistic view. Sorry about that.
No, it's good. Are any other thoughts or comments in the room? Y'all look like you've been at ESIP all week.
All right, Rich has one more.
I want to fight for my model data set as an item. So yeah, I looked at that document that you guys wrote, like Dave, and I don't know. It seems like the pros for model data set as items like were pretty strong, and the cons were kind of weak. And I just want to say that I use the ERIE, the German climate DKRZ. Their ERIE project, EERIE, is an amazing, like, I think for me it's like an exemplar for how we should do modern model workflows. And they do bit information, they do like rechunking, they do the stack catalog, they created grid look, which Eli Holmes showed that renders in the browser. They have Cloudify, which like gives you S3 access to your on-prem storage through software, just so you can access the data sets that didn't go into true object storage. Anyway, they do model data sets as items.
Well, I'm looking at their collection. It looks like a model data set to me.
They have a collection of model data sets.
Do you have it up, Dave? Do you mind sharing?
Oh yeah, I'll put this on the screen. I think so. I'm not fighting here. I agree with you, Rich. But I guess I'll point out that this collection, kilometer scale ESM output through the kilometer scale cloud, is a model data set. And it happens to contain items that form a collection, which is a data, and each one can be thought of as a data set, but it actually belongs to a bigger collection that somebody might want to iterate over. And the point I'm making about collections in Stack is that things that can be iterated over ought to be in a single collection the way they're doing it here. Yeah, and there's going to be complexity that needs to be represented in various ways within these collections. And it's in our interest to, like, at this level, to have a list of all the variables that are available and maybe have a single EDR endpoint that allows you to go through all this stuff and access it in that way. But there's always special circumstances, and it's totally cool to have different layouts in those special circumstances. Does that help bridge the?
Yeah. Thank you, Dave.
And one more comment from Tom.
Hello. Sorry. I just wanted to go back to something else. You mentioned this idea of like, oh, it'd be great if we could have X-ray like write out convention or compliant stuff immediately. But speaking as an X-ray maintainer, you can't do much there because it's a domain agnostic tool. And like the radio astronomers and condensed matter physicists who also use X-ray, they're not the main users, but they're there, would be very annoyed if X-ray changed its behavior to output to automatically comply with the climate and metadata conventions that have nothing to do with what they do. And so there's only a few small places where we can really like make ground with. We can make stuff opt in. We can make it opt in, but we can't make it like the default without breaking this for all these other people in all these other fields. And this is just like the downside of having domain agnostic tools. Like you do have to like make a separation.
Yeah, the way that currently works, right, is via like a plugin entry point, which happens with backends, and I think has been discussed quite extensively for CF encoding and decoding, right? And so then you could swap out CF encoding and decoding with NZ, etc.
Yes.
Yeah, and decouple NZ from CF, like so NetCDF, the NetCDF users guide, the NUG, is domain agnostic, and that's why NetCDF has been reused by so many domains. And then CF layers all this spatiotemporal kind of interpretive metadata on top of NetCDF. And I think that was my goal with NZ was we need a domain agnostic layer that says this is how this spatiotemporal array stuff gets done. Or not even spatiotemporal. This is how this array stuff, dimensional array stuff gets done in ZAR, right?
So
but I recognize that some people are going to be upset if you start adding a conventions equals this to their ZAR files. So it would have to be opt-in for sure.
Yeah. Yeah. But so just to clarify the current state, X-Ray currently has a plugin system for when you open data from a file. And there's like various CF apparatus there. I can't remember how much of that is actually opt-in or opt-out. There might it's complicated. Like it's a 12-year-old library. Like, but then when we write data out, there isn't actually even a plugin system there at the moment. Like I suggested it on a GitHub issue like years ago, but like no one actually has built that.
And for reading it, it's tied to the data format in a way that is challenging. Like right now, like for example, EOPF and I think many others have their own like EOPF-ZAR backend where they have to do the work of parsing ZAR's data format to X-ray as well as the metadata. Whereas it would be nice if those were separate. Like you could use ZAR backend and like CF decoding backend as isolated components. Recognizing that that would be a big refactor for X-ray and things like tied together in a way to work, right?
Yeah, but I agree. But like just to bring it to a more general point, like in general, this migration of formats, like from like pre-cloud kind of HDF to like cloud ZAR and stuff, gives us an opportunity to correct some of these mistakes if we can. Like I would really like to see a world where like data is in a generic array format that doesn't make assumptions about what field of science you're in, but then there are very clear metadata conventions layered above it, even if it requires a complicated plugin system to do that. Like that's incredibly powerful. And that's like the North Star that we should be trying to work towards here, rather than we want to move away from the coupling between domains and metadata standards and file formats, like, in my opinion.
Yeah. And I think that, like for ZAR specifically, the convention framework, I'm pretty optimistic that it provides a good basis for that. It's like we could use it and still like redo the coupling on top of a nicely domain agnostic and like composable ecosystem, or spend more work and do it in like the like architecture you're describing. And I definitely agree with you that having it be nicely decoupled is important for how we use it.
Yeah, and at the end of the day, like if you're going to use a ZAR convention, I feel like there needs to be a way to declare that you are using it when you write ZAR, right?
Yeah, there is, and it's just it's a matter of making it easy.
Okay, and that I think that becomes, I think you should be allowed to write a convention compliant data set that doesn't declare its conventions, but it should also be the happy path to write a convention compliant file that does declare its conventions. Right.
You would have enjoyed a multiple hour long debate that happened at the ZAR Summit about this exact question.
We could recreate it. I hope there will be another SR Summit. If anyone has opinions about that, you should definitely let us know because it's early brainstorming stages for that.
All right, we're at time. I'll leave us with this. I've put my hand up to do IT and I again, and the topics we've discussed here are absolutely going to inspire some future talks. So some of you in the room are going to be invited back for some more of this, which I love it. Hopefully other people do. And I took a few minutes. We've got a recording. I don't know exactly where all this goes from this, but hopefully this was a useful session for everybody. I'm really sorry I wasn't able to be there in person. But unless there's other, I guess I'll stop there and see if there's other closing thoughts.
Just want to thank you for leading IT and I, and both you and Ethan for all your work connecting these different standards. I think it's super important. And I appreciate that y'all have been the one making sure that we're keeping in touch and both with each other and the broader communities. So thank you.
Yeah, and thanks everybody for coming. It's been a good discussion. All right. I guess we can wrap it up then.
Bye, everyone.
Go get some lunch. Take care, everybody. Thank you.
See y'all. Bye.